Rules for track and IPC standards. Rules for track. Minimize track length. Shorter tracks reduce signal resistance, delay, and crosstalk, improving signal integrity. Longer tracks may require wider trace sizes to maintain signal integrity. Can be strategically placed in low-current areas of the circuit if necessary. Prioritize 90-degree angles. They offer good manufacturability and signal integrity, simplifying the fabrication process and minimizing signal reflections. Avoid sharp angles. Less than 45 degrees, these can introduce signal reflections and increase noise. Use curved segments or mitered corners if necessary. Smooth and rounded track junctions. These minimize signal reflections and stress concentrations, improving signal integrity and reliability. Avoid sharp corners and abrupt changes in direction. These can create stress points and increase the risk of track damage. Choose an appropriate track size based on several factors. Desired current carrying capacity. Wider tracks can carry higher currents without overheating. Track length. Longer tracks may need wider traces to maintain signal integrity. Minimum clearance to other tracks and pads. Maintain a minimum distance to prevent electrical shorts. Manufacturing capabilities. Consider the limitations of the PCB fabrication process, as very thin tracks might be difficult to manufacture reliably. Use PCB design software features. Most software offer built-in calculators or design rule checkers that suggest appropriate track sizes based on the chosen material, layer thickness, and desired current rating. It's recommended to consult the software's documentation and manufacturer recommendations for specific guidelines. Additional considerations. Signal type. High-frequency signals may require special considerations, such as controlled impedance tracks or specific dielectric materials. Thermal management. In high-power applications, thicker traces or heat sinks might be necessary to dissipate heat effectively and prevent damage. Study of IPC Standards. While there isn't a dedicated IPC standard solely focused on schematic design, several IPC standards provide guidelines and recommendations that indirectly influence schematic creation. These include IPC 2221, Generic Standard on Printed Board Design. This standard provides general principles for PCB design, including aspects like component placement, signal routing, and design for manufacturability (DFM). While not directly focused on schematics, it emphasizes clear and concise communication, which translates to well-structured and documented schematics. IPC 2581, Generic Standard for Interconnecting Electronic Assemblies. This standard defines standardized formats for exchanging design data between different software platforms, including schematic information. Adhering to IPC 2581 ensures schematics are interpretable by various PCB design tools. IPC 2221, Generic Standard on Printed Board Design. This standard is considered the primary reference for general PCB design practices. It covers a wide range of topics, including design rules and guidelines for track spacing, hole sizes, component placement, and other aspects. Material selection based on application requirements. Design for manufacturability, DFM, principles to ensure the PCB can be efficiently fabricated. Design for testability, DFT, considerations for easier troubleshooting and verification. IPC 4101, specification for base materials for rigid and multi-layer printed boards. This standard defines the requirements and specifications for various PCB base materials commonly used, such as FR4 and other epoxy laminates. It specifies properties like mechanical properties, e.g., thickness, strength; electrical properties, e.g., dielectric constant, loss tangent; thermal properties, e.g., glass transition temperature, thermal expansion coefficient. IPC 2581, Generic Standard for Interconnecting Electronic Assemblies. As mentioned earlier, this standard defines standardized formats for exchanging design data, including schematic information, netlist data, connectivity information, bill of materials (BOM), PCB layout data, Gerber files. This ensures seamless communication between the designer and the PCB fabrication house, leading to accurate and consistent PCB manufacturing. IPC A610, Acceptability of Electronic Assemblies. This standard provides guidelines and criteria for inspecting and evaluating the acceptability of soldered electrical and electronic assemblies. It covers aspects like solder joints, component placement, and overall assembly quality.